All right, now let's look at a much more interesting case. This is a little graph set 4, if you bump up a couple pages. Um, what we're looking at now is that you are being given, instead of starting with the position versus time graph, you're actually being given the velocity time graph. So this tells a little bit different story. And so again, you want to kind of, instead of just staring at a black and white graph, you kind of want to picture, something moving, kind of picture an object in your mind. And the story that this graph tells is, for the first 2 seconds, what's happening is this thing is actually moving, right? Because the meaning of being up here on the graph is this means 3 meters per second, right? Being here. So you're basically then moving at 3 meters per second for the first 2 seconds. Then after the first 2 seconds, it stops moving. So this says move at a constant speed for a while and then quit moving. Okay. So to sort of start with the easy part that builds off what we did before is, if we quick make the acceleration graph, what you notice is this thing is moving at 3 meters per second without changing speed. Well, that means that you're not accelerating for the first 2 seconds. Okay. Or you could think of it as the slope of this graph is 0. Here, what then happens is, so we were moving at a constant speed of 3 meters per second, and then we start moving at a constant speed of 0 meters per second. So again, you have no changing speed during these last 3 seconds, so then you must not have any acceleration. So this is flat, right? Another way to get it, of course, is that this bottom graph is the slope of the one above it. So the slope was 0, the slope was 0. For this brief instant in time, this slope was nearly basically negative infinity. So if you want, you could kind of have a little temporary spike down to negative infinity. And then you have a slope of 0, again, a stage where you're not accelerating. So that's what we looked at before. Now, though, what we haven't done yet is to go the other way. So there's a couple ways to think about this, and I kind of want to cover them, both of them. So one way to think about this, if we're trying to get the position graph, is we could say, well, during the first second, so the meaning of this thing is going at 3 meters per second. If we go at 3 meters per second for 1 second, let's just do it one at a time, right? 3 meters per second for 1 second, well, then you're going to move 3 meters, okay? So you know that after that 1 second goes by, you should be 3 meters up, right? And so you know then that after 1 second, you should be there, right? So that's one way to think about it. Another way to think about it is, that this graph is the slope of the one that's above it. So whatever's above it should have had a slope of 3. So that means for the first second, it should have a slope of 3. And likewise, you can see that for the next second, it should also have a slope of 3. So what we want to do is go up another 3. So let's double check that. If we were going in reverse, you would say, oh, the slope was 3 for the entire first 2 seconds. And that's why this is 3 meters per second for the entire first 2 seconds, right? So we've sort of looked at that way of looking at the graphs before. A new way to kind of see this, though, is if you notice that we're going 3 meters per second for 1 second, right? If you multiply this distance on the graph, I guess, okay, this interval, which is 3 meters per second, by 1 second, what you notice then is that you actually get the area of this little chunk. So this thing has an area of 3 meters, right? Now, why is that? Because 3 meters per second times 1 second, just by unit cancellation, right, gives you 3 meters. So you have an area of 3 meters. That's how far up we moved. We moved 3 meters. In the next second, we move up another 3 meters. So you can see we're using the area under this graph actually tells you how far to move. Then you get to this stage where the velocity is 0 for the final 3 seconds. Well, what that means is you just shouldn't move. From wherever you start, you shouldn't move. And so for these 3 seconds, we should stay put. Now, something I forgot to mention at the outset is The story this graph tells you is that you're moving 3 meters per second for the first 2 seconds, then quit moving. What is nowhere in this graph is where to start. And so you'll notice whenever we go this way, I have to tell you where we started. Okay. Those of you that are calculus hot shots will know that I'm tricking you into doing something called an integral right now. And there's an arbitrary constant that you get when you go this way. When you go this way, you're reading the slope. When you go this way, you're going to be reading the area. Okay. So notice the area under the graph for the first second was 3. We went up by 3. The area under the graph in the next second was 3. We went up by another 3. Now there's no more area, flat. And then what's really beautiful and satisfying about all this is you can double check it by going the other way. Slope was 3, slope was 3, slope is 0, slope is 0. Okay?